In this mini series, which is titled AI, a Practical Guide for Everyone, we will offer a beginner friendly exploration of AI concepts tailored for non technical students, professionals, and anyone who is curious about AI. It carefully balances accessibility with depth, providing insightful content without overwhelming technical jargon. By working through this series of episodes, you'll have a bit better understanding on how to navigate the world of AI. Some of the objectives are to provide a foundational understanding of core AI concepts, enable participants to understand and discuss AI in everyday context, to explore the practical applications and ethical implications of AI. So I hope you'll stay tuned for our mini series about AI. Lesson one of AI, a practical guide for everyone. So, what is AI? My mom is in her 80s and she's not aware of any technology trends. She doesn't charge her flip phone, and thank goodness it has a long battery life. And I thought of how I would have to explain AI to her, and here's what I came up with. Imagine AI is like a really smart, friendly robot that learns and gets better at things with practice. It can be taught to do things that are pretty simple, and it can take feedback to do things better. When we teach AI, we give it a lot of examples and it learns patterns. So over time, it can recognize pictures, understand words, hear sounds, and play games. It is a lot like teaching a dog tricks. So, what are some benefits of AI? It can help us with chores, it can make things safer, it can create cool things, it can help with learning. And how does it do that? With the boring administrative stuff, maybe like sorting emails or finding information really fast, it's very good at that. It can help cars drive themselves, which could make roads safer. It can also help doctors find illnesses earlier and reduce their administrative burden. It can help artists and writers create amazing pictures, music, and artwork, but it can also help scientists discover new things. AI can help with learning. They can teach you new things, or it can help you practice things that you are having trouble with. But there are some risks. Sometimes AI makes mistakes because it learns from examples. If the examples are wrong, it can make bad decisions. People might use AI for bad things. We're seeing that a lot with phishing scams and using it to break passwords. Some people might use AI to trick others into doing harmful things. AI could take away some jobs, but it could also create new jobs. AI can be biased. If the data that we train the AI on has bias, the AI will also be biased as a result. That means it might treat people unfairly. Here are some general key terms that you should be familiar with. AI, also called artificial intelligence, is the broad field of creating machines that can simulate human intelligence. Machine learning is a subset of AI where computers learn from data without explicit programming. So it's kind of like the AI is teaching itself a little bit. Deep learning is a type of machine learning using neural networks to analyze complex data. Neural networks are computational models inspired by the human brain used for deep learning. An algorithm is a set of rules or instructions that a computer follows to perform a task. It's kind of like a recipe. Data is any information that can be used to train and improve AI models. It could be written word, it could be pictures, it could be sounds. A data set is a collection of data that is used to train or analyze for the AI model. And a model is the output of the machine learning algorithm, and it represents the learned patterns. So here are some common applications and related terms. NLP, or natural language processing, is how AI understands and processes human language. Generative AI, or Gen AI, is AI that can create net new content like text, images, videos, or music. Automation is using technology to perform tasks automatically. Robotics is the design, construction, and operation of robots. Computer vision is AI's ability to see and interpret images, kind of like humans see with their eyes. A chatbot is an AI-powered program that simulates conversation. You've probably seen a lot of these if you're, web shopping or trying to do service at your bank. Here are some ethical and societal terms as they relate to AI. Bias is prejudice in data or algorithms that can lead to unfair outcomes. Ethics is the moral principles that guide AI development and use. Transparency is the ability to understand how AI systems make decisions. Privacy is protecting personal information from unauthorized access. Accountability is being responsible for the actions of AI systems. Explainability is the ability to understand how an AI arrived at a specific decision or outcome. Hallucination is when an AI creates false information or output, but presents it as true. In this episode of AI, a practical guide for everyone, we'll discover a brief history of AI. It's a fascinating journey from philosophical musings to the powerful technologies that we see today. And it's not necessarily a new idea. The concept of artificial beings appear in ancient myths and stories, like those of automata. In the 1940s and 1950s, we had the birth of AI. World War II and the development of computers laid the groundwork. Alan Turing's computing machinery and intelligence in 1950 proposed the Turing test, a measure of machine intelligence. The Dartmouth Workshop of 1956 is considered the official birth of AI as a field. In the 1950s to 1970s, we saw the golden age and some very early enthusiasm. Early AI programs that solved puzzles and played games. Researchers were optimistic about rapid progress, and early AI focused on symbolic reasoning. In the 1970s and 1980s, we saw the AI winter. Early AI systems struggled with complex problems. Funding for AI research decreased due to unmet expectations. Expert systems emerged showing some practical applications. Then in the 80s and 90s, we saw a resurgence and some machine learning. The rise of machine learning, especially statistical models, gained traction around this time. Increased computing power and data availability fueled progress. Neural networks began to gain more attention. In the 2000s to 2010s, we saw the deep learning revolution. Deep learning, with its powerful neural networks, achieved breakthrough image recognition, speech recognition, and natural language processing. The availability of massive data sets and powerful graphics processing units accelerated progress. AI became a buzzword once again. And from about 2010 until now, we're seeing AI in everyday life. It's everywhere and it's in everything. Some of it is hype and some of it's real, and some of it still needs a lot of work. And what we've seen is kind of a rebranding and small, slow evolution of some core aspects that work really well. AI is now integrated into many aspects of life: smartphones, virtual assistants, recommendation systems, and self driving cars. Gen AI tools have caused huge surge in public awareness. Ethical concerns and discussions about AI's impact on society have become increasingly important. Large language models are pushing the boundaries of what AI can do. In this episode of AI, a practical guide for everyone, part 1, lesson 3, we'll review some AI myths and misconceptions. Since AI is always in the news and the story is always changing, it's easy to get caught up in trendy, sensationalized portrayals of AI. And that leads to some common myths and misconceptions. So here are a few to take note of. Myth number 1: AI is going to take over the world. While AI is powerful, it's still far from achieving the kind of general intelligence seen in science fiction. AI is a tool, and its capabilities are limited by its programming and data. Myth number 2: AI is always accurate and unbiased. Well, that would be great, but it learns from the real world. And if that data is biased, the AI will be too. AI can make mistakes, especially when dealing with new or complex situations. Myth number 3: AI is only for tech experts. In fact, AI is becoming increasingly accessible to everyone. Many AI powered tools are designed for everyday use, and understanding basic AI concepts is becoming essential for absolutely everyone. Myth number four: AI is going to replace all human jobs. While AI can automate some tasks and can create some new content, it will also create new jobs and augment existing ones. The focus should be on adapting to the changing job market and developing skills that complement AI. Next myth is AI is a single monolithic entity. Well, the reality is that AI is a broad field with many different subfields, specialties, and technologies. There's no single AI, but rather a collection of diverse tools and techniques. Another myth: AI is always conscious or sentient. Well, the reality is that current AI systems are not conscious or sentient. They operate based on algorithms and data, not feelings or self awareness. Another myth I've heard: AI is magic. Well, the reality is AI is based on mathematical and computational principles. While it can seem magical at times, it's ultimately a product of human ingenuity and engineering. The next myth: AI is always futuristic. The reality is that AI is already integrated in many aspects of our daily life, from recommendation systems to virtual assistants. And the last myth: AI is only robots. Robots are a part of AI, but AI is also the algorithms that power programs and other computer based systems. In this episode of AI, a practical guide for everyone, we'll discuss some everyday applications and some lesser known examples of how we use AI. So, for example, Siri, Google Assistant, Alexa, Gemini all use natural language processing to answer questions, set reminders, and control devices. I have a Google device that I ask for the news and weather every morning when I'm making my coffee. Very handy, and that technology has been around for quite a while. Recommendation systems like Netflix, Spotify, and Amazon will analyze your data and suggest personalized content and products. So, for example, I buy a lot of running shoes, running shorts, running gear. So it knows to kind of feed me that type of content to try to get me to buy more stuff. For navigation, we've got things like Google Maps and Waze. They use AI to optimize routes, predict traffic, and provide real time updates. Again, we've been using that for a pretty long time now. We've got social media filters and facial recognition. These use AI powered algorithms that recognize faces in photos and videos. There are email spam filters that use machine learning to identify and filter unwanted emails. And if you've ever been on a website trying to buy something or get customer support, you've probably seen an online chatbot. They provide customer service and answer frequently asked questions. I recently had to cancel a software subscription. And when I realized it was an AI chatbot, I thought, oh my gosh, this is going to be a nightmare. And it actually was the fastest, easiest transaction that I've done. And it solved my problem probably in about 3 minutes, and I didn't have to wait. So it is getting better. Some lesser known examples are your smart thermostats, like your Nest. They learn your user preferences and automatically adjust temperature to optimize energy efficiency. They are used for fraud detection in banking. So AI algorithms can analyze transaction patterns to identify and prevent fraudulent activity. I have a credit card that I use to pay for tuition, and it's a tuition for university that is not in my home country. And it gives me a hard time every single time because it's a transaction that only happens twice a year. And it doesn't look like it fits in my normal pattern. So I always have to call customer service to get it to go through. If you use any news feeds, it will personalize and curate news articles based on your interests and preferences. AI is used in agriculture, so there's sensors and machine learning to optimize crop yields, monitor soil conditions, and detect diseases early. For medical imaging analysis, AI algorithms can assist radiologists in detecting abnormalities in X rays, MRIs, and CT scans. AI has also been used in language translation, and it's almost seamless. It's really neat how that works. AI can be used in retail inventory management. So the algorithms that predict customer demand and optimize stock levels to prevent shortages and overstocking. This is really helpful for seasonal shopping, especially like around Christmas or maybe back to school in September. AI can be used in music composition. Some programs can generate original music. There was a video, I don't know if it was that recent, maybe a few weeks ago or a couple months ago, and it showed a known artist creating completely original music only by the AI based on his style and previous music history. Was kind of terrifying, but that's where we're at now in terms of quality. AI can be used in writing, so they can help with grammar, spelling, tone, and they can revise or provide content for you. AI can be used in accessibility tools, programs that read text out loud for hearing or visually impaired users. They can generate captions for videos and help people with disabilities. AI can also be used in traffic light optimization. So it studies the traffic flow in real time and adjusts traffic to reduce congestion. So, if you think about these known ways and lesser known ways, what are some ways that you might use AI at home, school, or work? And what is one thing you could do to use AI that you're not doing now? In this episode of AI, a practical guide for everyone, we'll talk about how AI learns. First, we give the AI tons of data. So we might show it lots of pictures of cats and dogs. And it's kind of like showing a dog, a puppy, different types of shoes to teach it what shoes are. Then it finds patterns. The AI is looking for examples, like it tries to figure out what makes a cat different from a dog or what makes a shoe. And it might be like your puppy noticing that some shoes have laces and some are made of leather. Then it'll make predictions based on what it has learned. Once the AI has seen enough examples, it can start making predictions. If you show it a new picture, it can guess if it's a cat or a dog. And then it's like showing your puppy a new shoe and it automatically knows not to chew on it. Then it gets better over time because you give it feedback. If the AI guesses wrong, we tell it it's wrong. We tell it why it's wrong. This helps it learn from its mistake and it gets better at recognizing patterns. It's like telling your puppy no when it chews on your shoe. And there's three main ways that AI learns. So we call them supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is a lot like having a teacher. We tell the AI the right answers so it learns to match the examples to the correct labels, like cat or dog. Unsupervised learning is kind of letting someone explore on their own. The AI finds patterns in the data without us telling it the right answers. Reinforcement learning is like playing a game. The AI tries different actions and gets reward for doing well, learning to make the best choices. Imagine a computer trying to learn the difference between apples and oranges. We give it hundreds of pictures of apples and oranges. The computer looks at the color, shape, size, and if the computer guesses apple and it's correct, it gets a reward. If it is wrong, it learns from its mistake. After seeing enough examples, it can correctly identify new apples and new oranges. The AI learns just by finding patterns in data, just like people see by learning, seeing, doing, and hearing over and over again. In this episode of AI, a practical guide for everyone, we'll talk about different types of machine learning. We briefly touched on supervised, unsupervised, and reinforcement learning as machine learning types. So let's go into a bit more detail. Supervised learning is like having a teacher guide you through the learning process. You're given labeled examples, and the AI's job to learn the relationship between the inputs and outputs. In supervised learning, an AI model is trained on a data set where each piece of data is labeled with the corrected output. The model learns to associate the inputs with the corresponding outputs. When presented with new unlabeled data, the model used what it has learned to predict the output. So with labeled data, there's input-output pairs. For example, a picture of a cat is the input, the labeled output is cat. For the training process, the model adjusts its internal parameters to minimize the difference between its predictions and the actual labels. Prediction is once trained, the model can predict the output for new unseen inputs. So maybe it recognizes the difference between a kitten and a full-grown cat. For example, we can have email spam detection. The input is the email, content, subject, and sender. The output is spam or not spam. The AI learns to classify emails based on patterns in the input data. Another example is image recognition. It sees an image of an animal. It could be a cat, a dog, or a bird, but the AI knows based on the objects in the image, and it can analyze pixel patterns to provide the correct output. Regression is an output as a continuous value. So, for example, house price prediction. There are some data inputs such as the size of the house, the location, the number of bedrooms. Maybe it has a pool or a garage, and the output is going to be the predicted price of the house. The AI learns to predict house prices based on the relationship between input features and historical prices. Another example could be stock price forecasting. It could look at historical stock data, news articles, and economic indicators. And then the output would be the predicted stock price. The AI is learning to predict stock prices based on historical trends and other related data. And that is not without controversy, but it's just provided here as an example. Data input is the labeled data that is fed into the AI model. The model makes an initial prediction based on its current parameters, and then it compares its prediction to the label and calculates the error. The model then adjusts its internal parameters to reduce the error. Steps 2 through 4 are repeated many times, gradually improving the model's accuracy. The trained model is then ready to be tested on a separate, fresh new data set to evaluate its performance on unseen data. The benefits are higher accuracy when trained on large labeled data sets, and it's well suited for tasks with clear input and output relationships. There are some limitations that it requires labeled data, which can be expensive and time consuming to obtain. The performance depends on the quality and quantity of the labeled data, and it can have bias based on the data that it was trained on. So, in summary, supervised learning is a powerful tool for building AI systems that can perform a wide range of tasks, from recognizing objects to predicting trends. In supervised learning is a type of machine learning where algorithms analyze unlabeled data to discover hidden patterns or groupings without human intervention. Essentially, the AI is left to its own devices to find structure within the data. So, unlike supervised learning, which relies on labeled data, unsupervised learning works with unlabeled data. The goal is to find inherent structures, relationships, or anomalies within the data itself. This is particularly useful when dealing with large data sets where labeling every data point would be impractical or impossible. There's a few ways that it does this. One is clustering. This involves grouping similar data points together. It works as an example in customer segmentation. A retail company might use clustering to group customers based on their purchasing behavior, allowing for targeted marketing campaigns. The AI identifies clusters of customers who buy similar products even without knowing beforehand what those groups might be. Another example might be image segmentation. So it could separate images into distinct regions based on color or texture. Another example is the technique that reduces the number of variables in a data set while preserving its essential information. This is dimensional reduction. It uses principal component analysis to simplify complex datasets by identifying the most important features, making them easier to analyze and visualize. Another way that this can be done is through association rule learning. This discovers relationships or dependencies between variables in a dataset. An example of this is market basket analysis. A supermarket might use association rule learning to discover that customers who buy bread also often buy milk. This information can be used to optimize product placement or create bundled offers. Another option is anomaly detection. This is the process of identifying data points that deviate significantly from the norm. For example, fraud detection. Financial institutions use anomaly detection to identify unusual transaction patterns that may indicate fraudulent activity. I previously gave the example of my tuition payment that's not done in my home country. So it sees this as a very unusual activity and makes me jump through hoops to get the tuition payment approved. With unsupervised learning, the AI algorithm analyzes the unlabeled data, looks for similarities, differences, and patterns. It then organizes the data into groups or reduces its complexity based on the identified patterns. The results can provide valuable insights for decision making, even without the explicit labels. It can uncover hidden patterns and relationships in the data. It's useful for exploring large, unlabeled data sets, and it can be used for tasks where labeled data is unavailable or expensive. There are some limitations, though. The results can be subjective and difficult to interpret. It can be challenging to evaluate the accuracy of unsupervised learning algorithms. The results can also be skewed by the data that is inputted. Unsupervised learning is a powerful tool for exploring data and gaining insights that would be difficult to obtain through other methods. And then the last type of learning, reinforcement, is where an agent learns to make decisions by interacting with an environment. It's like teaching a new dog tricks by giving it treats when it does something right. The agent learns through trial and error and receives rewards for correct actions and penalties for incorrect actions. The goal is to maximize the cumulative reward over time. Reinforcement learning is particularly useful for tasks where there's no clear right answer. So the best course of action needs to be discovered through exploration. The key components are an agent, which is the entity that learns and makes decisions. The environment is the external world, which the agent interacts. The state is the current situation or context of the environment. An action is a decision made by the agent. A reward is a feedback signal indicating the desirability of an action. And a policy is the strategy the agent uses to choose actions based on the current state. It works in 6 steps, basically. So there's observation, in which the agent observes the current state of the environment. The action selection is how the agent chooses an action based on its current policy. The action execution is how the agent performs the chosen action in the environment. The reward reception is how the agent receives a reward or penalty from the environment. The policy update is how the agent updates its policy based on the received reward, aiming to maximize future rewards. And then there's the iteration, where these steps might be repeated several times over and over, which allows the agent to learn and improve. So some examples, because that probably sounds a little bit complicated. You can have a game playing agent that plays against itself or opponents. The environment would be the game board and the rules. The state is the current board configuration. The actions are the possible moves. The reward is winning the game. And the agent can play over and over again until it figures out how to improve its policies and rules. Another example is how a robot might learn to navigate a complex environment. There's been a lot of videos on YouTube and the other platforms on this lately. The environment is the physical space, and the robot is trying to learn how to navigate this complex environment. And the state is the robot's position and sensor readings. The actions are the robot's movements, and the reward is the robot reaching a target destination or avoiding obstacles. Another example is autonomous driving. So a self-driving car is learning to navigate the roads. The environment is the road network and traffic conditions. The state is the car's position, speed, and sensor data. The actions are the steering, acceleration, and braking. The reward is reaching the destination safely and efficiently. Another option to explore as an example is recommendation systems. So a program learns what content a user wants to see or buy. The environment is where the user is shopping or maybe listening to music or watching videos. The state is what the user is currently viewing or listening to or has purchased, and their past history. The action is driving what content is shown to the user, whether that's buying new sneakers or a new artist or a new TV show. The reward is the user watching their content and giving positive feedback or making a purchase. The benefits are that we can learn very complex behaviors in dynamic environments, and it's effective for tasks that have delayed rewards. and it can adapt to changing environments. However, there are some limitations. It requires a well defined reward function. It can be extremely expensive to run. It can be difficult to train in sparse reward environments, and it can be unpredictable during training. In this episode of AI, a practical guide for everyone, we'll discuss examples of machine learning. So there's different types of data that we use for machine learning. One example is text data, which could be from articles, books, social media posts, blogs, emails, code. And the applications of using this are sentimental analysis, language translation, text summarization, and chatbot development. Another type of data could be from images like photos, videos, medical scans, or satellite imagery. And applications for this are computer vision tasks like object detection, facial recognition, image classification, and optical character recognition. We can also have audio data from like speeches, recordings, music, or sound effects. The applications of audio data are for speech recognition, speaker identification, music genre classification, and sound event detection. I actually made a call to my bank last week and it said your voice will be used to validate your identity. And I was like, oh, okay. How did you get that? I'm very curious. There's also video data. So this could be movies, commercials, TV shows, surveillance footage, drone footage. And applications of this type of data are video analysis, action recognition, object tracking, and video summarization. There's also numerical or tabular data. So that could be from spreadsheets, databases, sensor readings, or financial data. And it could be used for regression tasks like predicting house prices or stock values, classification tasks like fraud detection and customer segmentation. There's also time series data, which is like stock market data over time, weather data that it's tracked over time, or sensor readings tracked over time. And applications for this are forecasting, anomaly detection, and trend analysis. There's also genomic data, which is based on DNA sequences and protein structures. This can help with the disease prediction, drug discovery, and personalized medicine. There's also sensor data. So there are environmental sensors, wearable data like your Fitbit or Apple Watch, and they can provide insights into predictive maintenance, environmental monitoring, and health tracking. For geospatial data, we can use satellite imagery, GPS data, and maps for urban planning, environmental monitoring, and navigation. Another topic of interest is how humanoid robots learn. Humanoid robots learn through a combination of machine learning techniques with a strong emphasis on reinforcement learning, which is crucial for tasks like walking, grasping objects, and navigating complex environments. The robot learns through trial and error and receives rewards for successful actions. There's also deep learning, in which neural networks enable robots to process visual and auditory information, recognize objects, and understand human speech. There's also imitation learning. Robots can learn by observing humans perform tasks. This involves analyzing human movements and replicating them. There's also simulation training. Robots are trained in virtual environments before being deployed in the real world. This allows them to learn and practice without the risk of damage or injury. Another option is sensor fusion, in which humanoid robots have many sensors like cameras, LiDAR, and tactile sensors, and they need to learn to combine the data from all the different sensors to understand their environment. There's also data collection and processing, in which humanoid robots are constantly collecting data from their sensors. This data is then processed and used to improve their performance. Another way they learn is through adaptive control, where the humanoid robots need to adapt to changing environments and unexpected situations. This requires them to learn and adjust their behavior in real time. There's also modular learning. Complex behaviors are broken into smaller, more manageable tasks. The robot learns each task separately and then combines them to perform more complex actions. These advancements in humanoid robots are moving fast, and their ability to learn and adapt will continue to improve as AI technology progresses. In this episode of AI, a practical guide for everyone, we'll talk about algorithms. Let's break down the what and why of algorithms. So, what are they? At their core, they're step by step instructions, kind of like a recipe. They can help solve a problem or complete a task. They're also like roadmaps or instruction manuals. So they provide a precise sequence of actions that a computer or a person can follow to achieve a specific outcome. Each algorithm has several key characteristics, like there's an input, there's a process, there's an output, there's uh, lack of ambiguity, and finite. So every task must finish or terminate. For the input, it's any type of data or instructions. For the process, it's a series of well defined steps or operations. For the output, it is a specific output or result. And examples that illustrate this in a bit more clarity. So, a recipe for baking a cake. You've got the ingredients flour, sugar, eggs as your input. The process is when to mix, when to bake, when to cool, when to decorate. And the final output is a cake. It has a firm endpoint too, so it is finite. A search algorithm. So if you've used any web browser, like, I don't know, Google, Bing, the input is the search words that you use. The process is how the web pages are indexed and how it matches keywords and ranks those results. And the output is a list of relevant web pages for you to go and explore. And it can also do sorting. So the input would be a list of numbers. The process is how it compares and swaps numbers until they are in the correct order. And then the output is a sorted list of numbers. So, why are algorithms important? And it breaks down to their ability to automate tasks, solve complex programs, and make informed decisions efficiently. Automation is how the algorithms enable computers to perform repetitive or time consuming tasks automatically. This frees up human resources. So, if you've ever thought about data entry, online transactions, or manufacturing processes, another example is problem solving. Algorithms provide structured approaches to problem solving that would be difficult or impossible for humans to solve manually. So, that could be predicting the weather, analyzing financial data, or designing complex structures. Algorithms can also use large data sets to identify patterns or trends that can inform decision making. For example, credit scores, medical diagnosis, and targeted advertising. Well designed algorithms can perform tasks much faster and more accurately than humans. For example, logistics and shipping, they can route packages and optimize supply chains. And algorithms are the backbone of innovation in fields like AI, machine learning, and data science. Developing new AI models, creating personalized experiences, and designing intelligent systems. In essence, algorithms are how behind computational processes and how they work. They are essential because they allow us to harness the power of computers to solve problems and improve our lives. So, one thing to think about is how 5 different AI tools impact your life daily. As we've discussed, they're in everything, they're everywhere. And if you've ever, used a music listening app or shopped online, or maybe you watch web shows, TV shows, movies online, you've definitely had these AI tools impacting your life. In this episode of AI, a practical guide for everyone, we'll talk a bit more about deep learning and neural networks. The term neural network sounds complicated and maybe even intimidating, but it is not so bad once you break it down. So here's how I would explain it to my darling mother. Imagine your brain is made up of millions of tiny helpers called neurons. They're like little messengers that pass information back and forth constantly. A neural network is a computer's way of trying to copy how those helpers work. So, what are neural networks? They are a type of computer program that learn by mimicking the way the human brain works. They're made up of layers of neurons that are connected to each other. When you show a neural network a lot of examples, it learns to recognize patterns and make predictions. For a more simplified explanation of how they work, there's an input layer, there's hidden layers, and there's an output layer. The input layer is where the information enters the network. Imagine showing the AI a picture of a cat. Each pixel in the picture is like a little piece of information that goes into the input layer. And then for the hidden layers, these are the thinking parts of the network. The neurons in these layers work together to find patterns in the information. They're like little detectives looking for clues. The output layer is where the network gives the answer. It might say cat or not cat. Neural networks learn by adjusting the connections between the neurons. If the network makes a mistake, it changes the connections to make it more likely to get it right the next time. This is called training. One relatable example might be how it recognizes pictures. So imagine you want to teach a neural network to recognize pictures of dogs. You show it thousands of pictures of dogs and thousands of pictures of other things, like cats and birds and apples. The network learns to find patterns in the pictures that are common to dogs. So it might look at pointy ears and tails and fur. Then, when you show it a new picture, it can guess whether it's a dog or not. For playing video games, neural networks can be used to teach computers how to play video games. This network learns by trying different actions and seeing what happens. If it does something that helps it win the game, it remembers that action and tries to do it again. Over time, it learns to play the game better and better. Neural networks can also learn how to write stories by reading lots of books and articles. They can learn to recognize patterns in language and use those patterns to create their own stories. Neural networks can also be used to translate one language into another. The network learns the pattern of each language and then can convert the text. When you ask a smart speaker a question, a neural network is used to understand what you said. The network breaks down the sound of your voice and compares it to known words and phrases. Neural networks can learn to do things that are very difficult for traditional computer programs. They can handle large amounts of data and find patterns that humans might miss. They're being used to create amazing new technologies like self-driving cars and advanced medical diagnosis. In this episode of AI, a practical guide for everyone, we'll talk about how deep learning powers advanced AI applications. This is done by enabling computers to learn complex patterns and representations from vast amounts of data, going far beyond what traditional machine learning methods can achieve. Here's a breakdown. Deep learning uses neural networks with many layers, hence the term deep. Each layer learns progressively more abstract features from the data. For example, in image recognition, the first layers might learn edges and corners. The middle layers might learn shapes and textures, and the final layers might learn entire objects. This hierarchical learning allows the AI to understand complex concepts by breaking them down into simpler, more manageable parts. Traditional machine learning often requires humans to manually engineer features, which is time consuming and requires domain expertise. Deep learning algorithms can automatically extract relevant features from raw data, eliminating the need for manual feature engineering. This allows AI to learn from unstructured data such as images, audio, and text, which is often difficult to process with traditional methods. Deep learning thrives on large data sets. The more data it has, the better it can learn and generalize. This is crucial for applications like image recognition, where millions of labeled images are needed to train accurate models. The increased size of the data sets that are available and the increased processing power of computers has allowed deep learning to flourish. Why do we need to do deep learning? There are several reasons, like complex problem solving, handling unstructured data, and achieving human level performance. It can also contribute to new innovation and generative AI. Deep learning has enabled breakthroughs in areas where traditional AI methods have struggled, such as image recognition. Recognizing complex scenes with high accuracy has been a challenge. Understanding and generating human-like text for natural language processing has also been a challenge. Transcribing spoken language with high accuracy and speech recognition has also been a challenge for traditional AI methods. Much of the data in the real world is unstructured, meaning it doesn't fit neatly into tables or databases. Deep learning can process and extract meaningful information from unstructured data, opening up new possibilities for AI applications. In some tasks, deep learning models have achieved or surpassed human level performance, such as in image recognition or game playing. This has led to the development of AI systems that can perform tasks that were previously thought to be exclusive to the domain of humans. Deep learning is a key driver of innovation in many key industries, such as healthcare, where it's developing new diagnostic tools and treatments, transportation, where it's enabling self driving cars, manufacturing, where it's optimizing production processes, entertainment, where it's creating new forms of art and media. With Gen AI, deep learning is the technology that powers it, which allows a computer to create new content. This is a very new and exciting era of AI development. In this episode of AI, a practical guide for everyone, we'll talk about deep learning and neural network examples. So they have permeated various fields and often operate behind the scenes, so you don't even know they're there. So here's a mix of common and some lesser known examples. So some common examples might be image recognition. So that's facial recognition to unlock your smartphone, object detection in self-driving cars, where it knows the difference between a tiny little squirrel and a toddler, so it doesn't run into them, and medical image analysis, so it could detect tumors or fractures. For natural language processing and language translation, like in Google Translate, voice assistants like Siri or Alexa, and sentiment analysis on social media. Also in recommendation systems, so product recommendations in e-commerce sites, and movie and music recommendations on streaming platforms. Some lesser known examples that you might not be familiar with include drug discovery, where it can predict the effectiveness of drug candidates, or it can identify new drug targets by analyzing biological data, or it can design new molecules with desired properties. For the field of materials science, it could predict properties of new materials, design materials with specific characteristics, accelerate the discovery of new materials for various applications. For financial fraud detection, it can analyze patterns to identify suspicious activity. It could predict the likelihood of fraudulent insurance claims, and it could detect market manipulation. For predictive maintenance, it can analyze sensor data from machinery to predict when maintenance is needed. It can reduce downtime and improve efficiency in manufacturing and transportation. For climate modeling, analyzing vast amounts of climate data can improve weather forecasting. Predicting the impact of climate change on different regions could also improve. We'd also be able to model complex climate systems. Agriculture, we could analyze satellite imagery to monitor crop health, optimize irrigation and fertilization, and detect plant diseases earlier. In the field of cybersecurity, we could detect anomalies in network traffic that could indicate a cyber attack. We could also analyze malware to identify its behavior. We could improve password security by generating stronger passwords. For astrophysics, we could classify astronomical objects from telescope data, detect exoplanets, and analyze gravitational wave data. In the field of biology, we have gene sequencing, where it can analyze large sets of genetic data to better understand diseases. It could also predict protein structures. For logistics and supply chain optimization, neural networks can help optimize delivery routes. We can also predict supply and demand changes. In this episode of AI, a practical guide for everyone, we'll talk a little bit more about language models. So language models are AI systems that can understand, generate, and manipulate human language. There are different types because they're designed for various tasks and optimized for various needs. Here's a breakdown. Statistical language models work using statistical techniques to predict the probability of a word or sequence of words occurring in a sentence. They rely on analyzing large amounts of text data to determine word frequencies and patterns. For example, n-gram models, which predict the next word based on a previous word. Why they exist is because early attempts at language modeling, foundational for tasks like speech recognition and machine translation. They're simpler and faster, but less powerful than newer models. We also have recurrent neural networks. They process sequential data by maintaining a memory of previous inputs. This also allows them to capture dependencies between words in a sentence. Long-term and short-term memory are gated recurrent neural networks, which are specialized recurrent neural networks that address the vanishing gradient problem. They exist because they're better at handling sequential data than statistical models, making them suitable for tasks like machine translation and text generation. However, they can struggle with long range dependencies. There's also transformers based language models that use an attention mechanism that allows them to weigh the importance of different words in a sentence. This enables them to capture long range dependencies and process text in parallel. BERT, bidirectional encoder representations from transformers, GPT, which is generative predicted pre-trained transformer, and T5, text-to-text transfer transformer are some examples. They exist because they've revolutionized language models due to their superior performance on a wide range of tasks. They can handle very large data sets and learn complex language systems. Large language models are transformer models that are trained on massive amounts of text data. They are known for their ability to generate coherent and fluent text and to perform a wide range of NLP tasks. Some examples include GPT-3, GPT-4, Lambda, and PaLM. They are developed to provide very general purpose language model, but they can be fine-tuned for many different tasks. They are generally the current state in terms of language modeling. There's also domain-specific language models. They are trained on text data from a specific domain, such as medicine, law, or finance. One example is BioBERT for biomedical text and LegalBERT for legal text. They're designed to improve performance on tasks within a specific domain by leveraging specialized knowledge. There are different types because of task specificity, data availability, computational resources, and performance requirements. Different models are better suited for different tasks. Statistical models are good for simple tasks, while transformers excel at complex tasks. The type and amount of data available can also influence the choice of model used. Some models require more computational resources than others. Statistical models are generally less resource intensive than transformers. The desired level of accuracy and performance can dictate the choice of model as well. Ongoing research leads to the development of new and improved language models constantly. We've also got small language models, or SLMs. They're gaining an increasing importance in the AI landscape. They are AI models designed to process and generate human language, but they have a significantly smaller number of parameters compared to large language models. This means they require less computational power and memory. This makes them more efficient and suitable for deployment in resource-constrained environments like mobile devices, edge devices, and applications that require processing offline. SLMs are less power hungry. It makes them faster and more energy efficient. They're easier to fine-tune for specific tasks or domains. Their lower resource requirements make them more accessible to a wider range of developers and organizations. And they can be deployed locally, which enhances data privacy and security. SLMs enable AI processing on edge devices, reduce reliance on cloud computing, and improve real-time responsiveness. The power AI features in mobile apps, such as voice assistants and real-time translation. They also excel at domain-specific tasks where they can be fine-tuned to achieve high accuracy. They offer a more affordable AI solution for organizations with limited resources. So, in summary, SLMs are making AI more accessible, efficient, and adaptable to a wider range of applications. In this episode of A Practical Guide for Everyone, we'll talk more about natural language processing and Gen AI. So imagine you have a super smart parrot that doesn't just repeat words, but actually understands what you're saying and can even respond in a way that makes sense. That's kind of what NLP is for in computers. In other words, NLP is how we teach computers to understand and work with human language. Instead of just seeing words as random letters, NLP helps computers understand meaning, like figuring out if you're happy, sad, or asking a question. It can recognize patterns like knowing that dog and puppy are related. It can generate text, like write a summary of a news article or answer your questions. When you talk to a voice assistant like Siri or Alexa, NLP is what helps it understand your voice commands. When you use a translation app, NLP helps it convert from one language to another. When you see a chatbot on a website, NLP is what allows it to have a conversation with you. When your email filters out spam, NLP helps it understand the contents of the email. When a program analyzes social media posts to see how people feel about a product, that is NLP at work. Basically, NLP bridges the gap between how humans communicate and how humans process information. It's about making computers language aware so they can interact with us in a more natural and intuitive way. Imagine you have a magic paintbrush that can create brand new pictures, stories, or music just by describing what you want. That's kind of what Gen AI is. In other words, Gen AI is a type of computer program that can create new things, and they look and sound as if they were made by a human. This is not without controversy, as I'm sure you're aware. But instead of just showing you things that already exist, Gen AI can create new pictures. Like if you say, I want you to show me a cat wearing a superhero costume, it can create it for you. It can write whole new adventures or stories based on a few keywords. It can create music in a specific style or match that of a particular artist, even if it's never been created before. It can also create very realistic videos. They're almost as good as real videos to the point where it's getting almost impossible to tell the difference between a Gen AI created video and a human created video. When you use a tool to create a picture from a text prompt, that's Gen AI. When you program writes a news article that sounds like a human wrote it, it's Gen AI. When you use a tool to create a song in the style of your favorite musician, that's Gen AI. When a program creates a realistic looking face or voice, that is Gen AI. It learns from a lot of examples and uses that knowledge to create something completely new. It's like a really creative artist that can make anything you can imagine. It has a lot of benefits, but there's also a lot of risks and drawbacks and things that have to be explored. In this episode of AI, a practical guide for everyone, we'll talk a little bit more about applications of NLP or natural language processing, because you encounter NLP throughout your day, often without realizing it. Some common everyday applications are voice assistants like Siri, Google Assistant, and Alexa. They understand your spoken commands and questions. They convert speech to text and vice versa, and they provide information and complete tasks. Search engines like Google and Bing understand the internet behind your search queries, provide relevant search results, and can correct spelling errors. Email spam filters analyze email content to identify and filter spam. This classifies emails into various categories. Chatbots and virtual assistants provide customer service and answer questions on websites and apps. They can very closely simulate human conversation. There's also language translation apps like Google Translate. They can translate text and speech from one language into another and break down language barriers. Texting and messaging apps autocorrect and provide predictive text. They have sentiment analysis of messages and can do voice to text. There's also social media monitoring, where we can analyze social media posts for sentiment, trends, and brand mentions. Some less commonly known examples are medical records analysis, in which it extracts information from patient records to improve diagnosis and treatment. It can also analyze medical literature to identify research trends. They can also do document analysis for legal work, so like legal contracts and documents to identify key clauses and risks, and it automates legal research. It can also do financial news analysis, where it reads the articles and financial reports to predict market trends. It can also detect fraudulent activity. There's also content moderation, where it analyzes online content to identify and remove hate speech, misinformation, and other harmful content. It can also detect online bullying. There's also sentiment analysis and market research. It analyzes customer reviews and feedback to understand customer sentiment and preferences. And then it helps produce reports that can provide product feedback to improve for future versions. For HR and recruitment, it can analyze resumes and job descriptions to match candidates with suitable positions or reject or approve certain candidates from moving forward in the process. It can also be used to review employee feedback to improve workplace culture. It can also provide automated summarization, which creates concise summaries of long articles, reports, or documents. This is a built-in feature of Adobe now. It can analyze customer support tickets and route them to the appropriate department and identify common recurrent customer issues. It can also be used to do call center recordings. Analyzing customer and representative dialogue can improve customer service. You can also find keywords that indicate customer satisfaction or dissatisfaction. This episode of AI Practical Guide for Everyone, we'll talk a little bit more about applications of Gen AI. It is a rapidly expanding field, and applications are becoming more diverse. So here are some common and lesser known examples. You've probably heard of ChatGPT, Bard, Claude. They can write articles, poems, scripts, novels, code. They can generate responses to questions and prompts. They can create chatbots and virtual assistants. They're pretty sophisticated. DALL-E, Midjourney, Stable Diffusion, and others can do image generation. They can create realistic, cartoon, or surreal images from text-based descriptions. They can generate variations of existing images, and they can create art and design concepts. There's also music generation like Music LM and Jukebox. They can compose original music in various styles or copy the style of an existing artist. They can generate variations of existing songs, then create sound effects and audio landscapes. Some lesser known examples include video generation, which is becoming more popular. They can animate still images, they can generate visual effects, and they can create short videos from text descriptions or images. There's also 3D model generation based on text descriptions or images, and they can design virtual environments and objects. You've also got some that can do code generation. So they can write complete applications at this point and automate a lot of software development tasks. For drug discovery, they can generate new molecular structures for potential drugs and predict the properties of drug candidates. For materials design, then they can create new material composition with desired properties or design materials for specific applications. In fashion design, they can generate new clothing designs and patterns and create virtual fashion shows. For architectural design, they can generate building layouts and interior designs and virtual architect visualizations. For video game development, they can generate game levels, characters, and storylines, as well as procedural content. They can create realistic voices that sound like real people from text or sound like a specific person after learning from their publicly available audio information. They can also generate training data, and that can be used to train other AI models. And then they can create personalized learning experiences. So that could be educational content and practice. In this episode of AI, a practical guide for everyone, we'll talk more about AI in action. In healthcare, AI is making significant strides, offering a range of applications that improve patient care, streamline operations, and accelerate research. For medical diagnosis, it can be used for image analysis and disease prediction. AI algorithms can analyze medical images like X-rays, MRIs, and CT scans to detect abnormalities such as tumors or fractures, often with greater accuracy than human experts. AI can analyze patient data, including medical history and genetic information, to predict the likelihood of developing certain diseases. For drug discovery and development, AI can generate and analyze vast amounts of data to identify potential drug candidates and predict their effectiveness. It can also help optimize clinical trials by identifying candidates and speed up the drug development process. For personalized medicine, it can provide treatment recommendations based on specific needs and genetic makeup of a particular patient. It can also predict how patients will respond to various treatments, allowing more targeted and effective care. For remote patient monitoring, AI-powered devices and apps can monitor a patient's vital signs and health data remotely, allowing for early detection of potential problems. Virtual assistants can also provide patients with information, schedule appointments, and answer questions. For healthcare administration, AI can automate administrative tasks such as scheduling appointments, processing insurance claims, and managing medical records. AI can also analyze large data sets to identify trends and patterns, helping healthcare providers to improve efficiency and reduce costs. For research and development, AI can analyze vast amounts of medical literature to identify research trends and accelerate the development of new treatments. AI is also used to analyze genomic data to better understand diseases and develop personalized treatments. AI's ability to process and analyze vast amounts of data is revolutionizing the healthcare industry, leading to more accurate diagnosis, more effective treatments, and improved patient outcomes. AI is also rapidly transforming the transportation sector, impacting everything from individual commutes to large scale logistics. So, here are some ways AI is being used in transportation: autonomous vehicles like self driving cars, trucks, and buses. AI is the core technology behind autonomous vehicles, enabling them to perceive their environment, make decisions, and navigate roads without human intervention. Computer vision, machine learning, and sensor fusion are used to process data from cameras, LiDAR, and radar. It can also be used for traffic management and optimization. AI systems analyze real time traffic data to optimize traffic light timing, reduce congestion, and improve traffic flow. Predictive analytics can forecast traffic patterns and identify potential bottlenecks. AI is also used to optimize public transportation schedules and routes. In the area of logistics and supply chain management, AI algorithms can optimize delivery routes, reduce fuel consumption, and improve delivery times. Predictive analytics can forecast demand, optimize inventory levels, and prevent supply chain disruptions. AI powered systems can track shipments and provide real time updates. For predictive maintenance, AI analyzes sensor data from vehicles and infrastructure to predict when maintenance is needed. This helps prevent breakdowns, reduce downtime, and improve safety. For ride sharing and mobility services, AI algorithms match riders with drivers, optimize routes, and predict demand. AI powered chatbots provide customer support and answer questions. In the field of aviation, AI is used for flight planning, air traffic control, and aircraft maintenance. AI powered systems can analyze weather patterns and predict turbulence. AI is also being explored for autonomous drones. For maritime transportation, AI is used for autonomous ships, route optimization, and cargo management. AI powered systems can analyze weather and ocean conditions to improve safety and efficiency. For rail transportation, it's pretty similar. AI is used for train scheduling, track maintenance, and passenger safety. AI powered systems can analyze sensor data to detect potential problems and prevent accidents. AI's ability to analyze vast amounts of data, make real time decisions, and automate tasks is revolutionizing the transportation industry, leading to safer, more efficient, and more sustainable transportation systems. In the field of entertainment, AI is rapidly transforming creativity, personalization, and efficiency in various ways. For content generation, which we've talked about in previous episodes, AI models are used to generate scripts, music, and visual effects, aiding in the creation of movies, TV shows, and video games. AI tools can create realistic looking images and videos, reducing the need for expensive sets and props. AI can generate personalized music playlists and soundtracks. For video editing and production, AI can automate tedious tasks like color correction, scene detection, and video editing. AI powered tools can enhance video quality and create special effects. For personalized recommendations on streaming services and gaming, AI algorithms analyze user data to recommend movies, TV shows, music, and other content. This enhances user engagement and satisfaction. AI powered game characters and opponents provide more realistic and challenging gameplay. AI can generate dynamic game environments and storylines and detect cheating. For audience engagement and analytics, like on social media, and for targeted advertising, AI can analyze data to understand audience preferences and trends. It can use sentiment analysis to help gauge audience reactions to movies, TV shows, games, and products. AI algorithms analyze user data to deliver personalized ads. I'm sure you've seen plenty of those. It also helps advertisers reach their target audience more effectively. For special effects and audio visuals, AI can create realistic looking digital actors and deep fakes. This technology raises ethical considerations about authenticity and manipulation. AI can automate and enhance visual effects processes, making it faster and more efficient to create stunning visuals. AI models can compose original music in various styles or in the style of a particular artist. They can enhance audio quality, enhance the editing process, and create sound effects. They can also clone voice for characters or narration. For procedural content generation, like in video games, the AI can generate game levels, environments, and characters, which save developer tons of time and resources. For NPCs, AI can create NPCs with more realistic and dynamic behaviors. In this episode of AI, a practical guide for everyone, we'll talk a little bit more about case studies of successful AI implementations. There are numerous compelling case studies showcasing successful AI implementation across various industries. So, Netflix, we know as our content streaming platform, they face the challenge of keeping their library of content relevant and engaging for millions of diverse users. The AI solution they implemented was a sophisticated recommendation engine powered by machine learning algorithms. This system analyzes your viewing history, ratings, and preferences to suggest personalized content. The result is that it increased a user engagement and had higher retention rates and had a significant competitive advantage. Netflix attributes a substantial portion of its viewership to its recommendation system. Another example is the Google search engine. Google needed to provide accurate and relevant search results for a massive volume of diverse queries. They heavily utilize AI, particularly deep learning, to understand search intent, rank web pages, and deliver personalized results. They also use AI in many other ways, from translation to image recognition. The result is that Google's search engine remains the dominant player, and their AI applications have revolutionized various aspects of online information access and other services. The Mayo Clinic uh, did some work where medical professionals needed faster and more accurate diagnostic tools, particularly for complex diseases. The AI solution they investigated used AI algorithms to analyze medical images, such as CT scans and MRIs, to detect abnormalities like cancer and stroke. The results were improved diagnostic accuracy, earlier disease detection, and better patient outcomes. JP Morgan Chase needed to deal with their fraud problems. So, as a financial institution, they face the constant threat of fraudulent transactions. The AI solution they implemented analyzed transaction patterns in real time to identify suspicious activity. The result was reduced fraud losses, improved security, and enhanced customer trust. Zara, the clothing store, decided to optimize its supply chain to quickly respond to changing fashion trends and customer demands. They implemented AI algorithms to analyze sales data, predict demand, and optimize inventory levels. The result was that it reduced inventory waste, improved efficiency, and it increased time to market for new products. Waymo, which is Google's self-driving car, wanted to create a safe and reliable self-driving vehicle. Waymo uses a combination of machine learning, computer vision, and sensor fusion to enable its vehicles to navigate complex road environments. Significant progress in autonomous driving technology with millions of miles driven in real-world conditions is the successful outcome. Salesforce CRM is another example. Their problem was they wanted to help businesses better understand and engage with their customers. They implemented Einstein, which integrates AI into their customer relationship management platform, and it provides insights and automation for sales, marketing, and customer service. The result was improved in customer engagement, increased sales, and enhanced business efficiency. These case studies are demonstrating the transformative power of AI across diverse industries, highlighting its potential to solve complex problems and drive innovation. And while they may not always be successful or the end result, and they're constantly changing, the idea is that we're still moving forward, we're still seeing advancements, and there's still potential to further test and refine these AI solutions. In this episode of AI, a practical guide for everyone, we're going to talk about the future of work because the impact of AI in science and discovery is poised to be transformative with both immense opportunities and potential challenges. Automation and augmentation are two big areas where we will see AI. AI will automate routine tasks, freeing up human workers to focus on more creative, strategic, and interpersonal work. AI will augment human capabilities, provide tools and insights that enhance productivity and decision making. The demand for skills related to AI and data science will increase. Soft skills such as critical thinking, creativity, and emotional intelligence will become more valuable. Continuous learning and upskilling will be essential for workers to adapt to the changing job market. AI will create new jobs and industries that we cannot yet imagine. New roles will emerge in areas such as AI development, maintenance, and ethical oversight. The impact of AI on science and discovery will be massive. Accelerated research, enhanced modeling and simulation, new tools and techniques, and data analysis are all areas where we will see changes. AI can analyze vast amounts of data to identify patterns and insights that would be difficult for humans to discover. AI can accelerate the pace of scientific discovery in fields such as medicine, biology, and material science. AI can create more accurate and sophisticated models of complex systems, such as climate change and disease spread. This can lead to better predictions and more effective interventions. AI is enabling the development of new tools and techniques for scientific research, such as AI-powered microscopes and telescopes. This is expanding the boundaries of scientific exploration. AI allows scientists to process very large data sets that would otherwise be impossible to work with. All that said, there are some key considerations. It is crucial to address the ethical implications of AI, such as bias, privacy, and security. Responsible AI development and deployment are essential. AI's impact on society will depend on how we choose to use it. It's important to ensure that AI benefits everyone and does not exacerbate existing inequalities. The speed of AI development requires that people and organizations stay adaptable to changes that AI presents. In essence, AI has the potential to revolutionize the way we work and conduct scientific research. By embracing the opportunities and addressing the challenges, we can create a future where AI benefits humanity. In this episode of AI, a practical guide for everyone, I'll give you some tips on how to practice your AI skills. Prompting in the context of AI is especially important, and it's the art and science of crafting effective instructions or questions to get the desired output from the AI. It's about communicating clearly and precisely with the AI to guide its creative or analytical processes. So, prompting is providing instructions. It's essentially a question or some background information to give the AI, and it can range from a simple phrase, like "What's the weather today?" or a complex multi-paragraph description. The quality of your prompt directly influences the quality of the AI's output. Effective prompting involves understanding how the AI interprets language and tailoring your instructions accordingly. It's an iterative process, and you do get better with practice. You may need to refine your prompt several times to get the desired result. Experiment with different phrasing. Try rewording your prompts in different ways to see how the AI responds. Pay attention to specific words and phrases that yield the best results. Be specific and detailed. Provide as much relevant information as possible in your prompts. Include details about desired style, tone, format, and content. Use keywords and context. Incorporate them that in such a way that the AI is likely to recognize them. Provide context to help the AI understand the purpose of your prompt. Break down complex tasks. If you have a complex task, break it down into smaller, more manageable prompts. This can help the AI generate more focused and accurate results. Don't be afraid to experiment and refine your prompts based on the AI's output. Provide examples of the desired output to guide the AI's generation. This could be particularly helpful for tasks like writing or coding. Experiment with different models and image generation models to see how they respond to different prompts. Each model has its own strengths and weaknesses. Look for examples of successful prompts online and analyze what makes them effective. Learn from the techniques used by experienced prompt engineers. Many online resources now exist, and they give great examples on how to use prompts and how to craft better prompts. And they also explain the best method for prompting. By practicing these techniques, you can develop your prompting skills and unlock the full potential of AI models. In this episode of AI, a practical guide for everyone, we'll talk a little bit more about bias and ethics. AI bias is a critical issue that arises when AI systems produce unfair or discriminatory outcomes. This occurs due to flaws in the data, algorithms, or objectives used to train and deploy these systems. Essentially, AI bias means that an AI system systematically favors certain outcomes over others. often resulting in unfair treatment of specific groups or individuals. This can manifest in various forms, leading to discriminatory practices results based on factors like race, gender, age, or socioeconomic status. Look for situations where the AI system produces significantly different results for different groups, even when they have similar characteristics. If the data used to train the AI is not representative of the population it will be used on, it is likely to be biased. AI systems can perpetuate harmful stereotypes if they are trained on data that reflects existing social biases. Regularly testing AI systems with diverse data sets and auditing their outputs for fairness is essential. Tools and methods that allow us to understand how an AI arrived at a specific decision are vital. The most crucial step to ensure that training data sets are diverse and representative of the populations that AI will impact is one way that we can address this problem. We also need techniques to identify and mitigate biases in the data before it's even used to train the AI. We also have to develop algorithms that are designed to minimize bias and promote fairness. Keeping humans in the loop for critical decision-making areas where AI biases could have serious consequences is essential. We also have to regularly monitor AI systems after deployment to detect and correct emerging biases. Making AI systems more transparent and holding developers accountable for biased outcomes is also critical. Creating and enforcing ethical guidelines for AI development and deployment it's a given. We need that. Addressing AI bias requires a multifaceted approach that involves technical solutions, ethical considerations, and ongoing vigilance. The ethical issues surrounding AI use and development are complex, encompassing concerns about fairness, privacy, autonomy, and societal impact. AI systems can perpetuate and amplify existing societal biases, leading to discriminatory outcomes in areas like hiring, lending, and criminal justice. Lack of diverse data and algorithmic flaws can result in unfair treatment of marginalized groups. AI-powered surveillance technologies raise concerns about the erosion of privacy and the potential for misuse of personal data. Facial recognition, data mining, and targeted advertising can introduce all kinds of security, autonomy, and freedom questions. As AI systems become more sophisticated, questions arise about their autonomy and the potential for unintended consequences. Autonomous weapon systems, for example, raise ethical concerns about the delegation of life or death decisions to machines. AI-driven automation has the potential to displace workers in various industries, leading to job losses and increased economic inequality. The benefits of AI may not be distributed equitably, exacerbating existing social disparities. The nature of some AI algorithms makes it difficult to understand how they arrive at decisions, raising concerns about transparency and accountability. It's essential to develop mechanisms for auditing and explaining AI systems. AI-powered tools can be used to generate deepfakes, spread misinformation, and manipulate public opinion. This poses a threat to democratic processes and social cohesion. Training and running large AI models, particularly LLMs, requires significant energy consumption, contributing to environmental concerns. The carbon footprint of AI raises questions about its sustainability. The hardware that powers advanced AI also has an environmental cost in production and eventual disposal. The benefits of AI may not be accessible to everyone, creating a digital divide between those who have and those who have not. This can exacerbate existing inequalities and limit the potential for AI to benefit society as a whole. The cost of hardware and data required to train and run AI means that only large corporations and well-funded governments can participate in the most advanced AI development and use. Many technologies can be used for both beneficial and harmful processes, raising concerns about their potential for misuse. It's essential to develop safeguards to prevent the development and deployment of AI for malicious purposes. Addressing these ethical issues requires a collaborative effort involving researchers, policymakers, industry leaders, and the public. In this episode of AI, a practical guide for everyone, we'll talk a little bit more about privacy and security. AI systems raise significant privacy concerns due to their ability to collect, analyze, and infer sensitive information about individuals. AI systems often require vast amounts of data, including personal information, to function effectively. This raises concerns about how this data is collected, stored, and used, especially when it's collected without explicit consent. AI can infer sensitive information about individuals from seemingly innocuous data, such as their online browsing habits or social media activity. This can lead to detailed profile of individuals, which can be used for targeted advertising, discrimination, or surveillance. AI-powered facial recognition and biometric technologies raise concerns about mass surveillance and the potential for misuse of sensitive biometric data. The nature of some AI algorithms makes it difficult to understand how they process and use personal data. This lack of transparency can erode trust and make it difficult to hold AI systems accountable. Large data sets held by AI systems represent attractive targets for cyber attacks, potentially leading to widespread data breaches and identity theft. AI models are trained on vast amounts of data, and sometimes data is obtained without the consent of the people that have created it. To minimize and address privacy concerns, it's important that we collect only the data that is absolutely necessary for the AI system to function. Avoid collecting sensitive information unless it's absolutely essential. We should also remove or replace personally identifiable information from datasets to protect individual privacy. We need to develop AI algorithms that can process data without revealing sensitive information, such as federated learning and differential privacy. We need to make AI systems more transparent by providing clear explanations of how they process and use personal data. We need to develop tools and methods for auditing and explaining AI algorithms. We also need to implement robust security measures to protect personal data from unauthorized access, use, or disclosure. We need to encrypt sensitive data and regularly audit security systems. We need to give individuals more control over their personal data by providing clear and easy to use privacy settings. We need to obtain informed consent before collecting or using personal data. We need to develop and enforce strong data privacy regulations that address the specific challenges posed by AI. Examples include the GDPR, or General Data Protection Regulation, and the California Consumer Privacy Act, or CCPA. We need to establish ethical guidelines and best practices for AI development and deployment that prioritizes privacy and data protection. We need to establish clear rules about how the data is used to train AI models. AI systems should have regular audits to make sure that they are following all the privacy rules. By implementing these measures, we can mitigate the privacy risks associated with AI and build trust in these powerful technologies. In terms of security, AI systems introduce a wide range of concerns, both novel and extensions of existing cybersecurity challenges. AI can automate and enhance cyber attacks, making them more sophisticated and difficult to detect. AI can be used to generate convincing phishing emails, create malware that evades detection, and launch targeted attacks on critical infrastructure. Attackers can manipulate the data used to train AI models, causing them to make biased or incorrect predictions. This can have serious consequences in applications like autonomous vehicles or medical diagnosis. Attackers can attempt to reverse engineer AI models to extract sensitive information or intellectual property. This can compromise the confidentiality and integrity of AI systems. Attackers can craft inputs that are specifically designed to fool AI systems, causing them to make errors or misclassifications. For example, adversarial images could fool self-driving cars into misinterpreting traffic signs. AI can be used to create realistic deepfakes and generate convincing social media profiles, enabling attackers to manipulate and deceive individuals. AI-powered surveillance systems can be used to track and monitor individuals, raising concerns about privacy and civil liberties. AI can be used to control systems in ways that are malicious. The security of the hardware and software that supports AI systems is vital. Attacks on these systems can cause widespread problems. So how do we address security concerns? We need to implement strong data encryption, access controls, and security monitoring to protect training data and AI models. We need to train AI models to be resilient to adversarial attacks by exposing them to a variety of manipulated inputs. We need to use AI to detect unusual patterns in network traffic and system behavior that may indicate a cyber attack. We need to develop AI systems that are transparent and explainable, making it easier to identify and mitigate security vulnerabilities. We need to conduct regular security audits and penetration testing to identify and address security weaknesses in AI systems. We need to use AI to analyze threat data and identify emergency cyber threats. We need to foster collaboration and information sharing between researchers, industry, government to address corporate security challenges and AI security challenges. We need to develop and enforce ethical guidelines and regulations for the development and deployment of AI systems. We need to harden the hardware and software that AI systems run on. We need to use these models to detect when AI generated content has been tampered with. By implementing these measures, we can enhance the security of AI systems and mitigate the risks that they pose. In this episode of AI, a practical guide for everyone, we'll talk a little bit more about the societal impact of AI. AI societal impacts are a complex mix of potential benefits and risk, creating both opportunities and challenges for humanity. We can improve healthcare. AI can lead to earlier and more accurate diagnosis, personalized treatments, and accelerated drug discovery, potentially saving lives and improving quality of life. Enhanced education. AI can personalize learning experiences, provide adaptive tutoring, and make education more accessible to everyone. It can increase productivity and efficiency. AI driven automation can streamline processes in various industries, leading to increased productivity and economic growth. AI can accelerate scientific research, enabling breakthroughs in fields like climate change, energy, and materials science. AI powered tools can enhance accessibility for people with disabilities, such as speech recognition, text to speech, and assistive technologies. AI powered autonomous vehicles have the potential to reduce traffic accidents and improve transportation safety. AI can be used to optimize energy consumption, monitor environmental conditions, and develop sustainable solutions. AI powered search engines and language translation tools give people access to more information than ever before. But there are some negative societal impacts. AI driven automation can lead to job losses in various sectors, potentially exacerbating economic inequality. AI systems can perpetuate and amplify existing societal biases, leading to discriminatory outcomes. AI powered surveillance technologies and data collection practices can erode individual privacy and civil liberties. AI can be used to generate deepfakes, spread misinformation, and manipulate public opinion, posing a threat to democracy. The development of autonomous weapons raises ethical concerns and poses a threat to global security. Over reliance on AI could lead to a decline in human skills and critical thinking abilities. We're starting to see studies come out on this now. Increased time spent interacting with AI systems could lead to social isolation. Those with access to AI and the knowledge on how to use it will have even more advantages over those that do not. Long term, some experts worry about the potential for superintelligent AI to pose existential risks to humanity. Navigating these impacts requires a proactive and collaborative approach involving ethical considerations, responsible development, and thoughtful policymaking. In this episode of AI, a practical guide for everyone, we're going to talk a little bit more about the future of AI. So it's a wild ride. It's up and down. It's chaos. Everything changes constantly. AI is getting smarter. It's becoming more usable. It's becoming practical. There are some failures and there are some success stories. Think about medicine. AI can help cure diseases we thought were impossible. It can personalize treatments, design new drugs, and help us understand the human body better. AI could sift through mountains of data and make discoveries that would take humans centuries. It could help us solve climate change and find new energy sources and explore the universe. And AI can take over all the boring, repetitive tasks that we dread doing. Then we could focus our time on creative, meaningful work and have more time for what matters. Education could be personalized, making learning more effective and accessible to everyone. We could even see AI helping us build smarter cities, manage resources better, and create a more sustainable future. But there is a darker side. What if AI takes away too many jobs? How do we retrain people and ensure everyone benefits from this technology? And what about bias? It'll make biased decisions, which could hurt marginalized groups. We need to be really careful about fairness and transparency. And then there's privacy. AI is collecting and analyzing so much data. How do we protect people's information? How do we stop it from being used to manipulate or control us? Plus, there's the deep fakes, which we know are happening. AI can make it look like anyone said or did anything, and we can't tell the difference. We don't know what is real. We don't know what is fake. So, how do we trust our information? The energy consumption of these models is alarming and huge. We need to find sustainable ways to power AI. Some people worry about AI becoming too powerful, like in the movies. What if AI develops its own goals and they don't align with ours? We need to have these conversations. Future of AI is in our hands. We need to be proactive, not reactive. We need to think about the ethical implications, the societal impact, the social impact, and how to make sure AI benefits everyone. It's not just about building cool technology, it's about building a better future, and that takes all of us.